In this task, we will look at Istio's circuit breaking capabilities for connections and outlier detection. Circuit breaking is an important pattern for creating resilient microservice applications. Circuit breaking allows you to write applications that limit the impact of failures, latency spikes, and other undesirable effects of network peculiarities. In this task, you will configure circuit breaking rules and then test the configuration by intentionally tripping the circuit breaker. Let's get started. In order to support the further tutorials, I have modified some of the code in the sample microservices. Going forward, we will use a new set of Docker images for our tasks. The customer's application will use the images present in the Spring Boot customer's basic repository in my Docker Hub account. The image with the tag 003 of this service works perfectly, whereas the image with the tag 003 exception has a storage issue, and the API always fails with an insufficient storage exception with a return code of 507. As you see, both the images are multi-architecture compliant. Let's first create the deployment and the service for the version v2 of this microservice that uses the healthy image. We'll wait for the pod to be up and running. Okay, so next we will create a destination rule with the following circuit breaking properties. The connection pool traffic policy HTTP1 max pending requests equal to 1 and max requests per connections equal to 1 means that if you exceed more than one connection and request concurrently, you should start seeing some failures when the Istio proxy opens the circuit for further requests and connections. For further details, you can visit the Istio documentation on the link shown on your screen. Let's apply this destination rule. Next, we will create a virtual service resource in the default namespace. We will name it customers, and it will have only a single default HTTP destination route for the host named customers. The destination route points to the subset named default, which was created in the previous step. So let's apply this virtual service. To generate some traffic to the customer service, we will use a client application. The client is a simple load testing application called Fortio. Fortio lets you control the number of connections, concurrency, and delays for outgoing HTTP calls. You will use this client to trip the circuit breaker policies you set in the destination rule. The manifest for the Fortio deployment is available in the downloaded Istio package. Using that manifest, let's create the Fortio deployment. We see now that the Fortio pod is up and running. We will save the name of the Fortio pod in an environment variable called Fortio pod. Now let's call the customer service with a single connection and send 20 requests. You should see that 100% of the requests respond with a success status code. You see in the output that all the requests succeeded with a status code of 200, and this is the expected result. Now let's break something. Let's increase the number of concurrent connections to 3 and run Fortio again. You should see now that some of the requests fail with status code 503, which means service unavailable. This means that the server is currently unable to handle the requests. In this case, the circuit breaker kicked in by trapping some of the requests, and you should see that some of the requests terminated with 503 status code. Your numbers below might be different. Let's query the Istio proxy to investigate how many calls so far have been flagged for circuit breaking. You should see the output matches the count of the responses with error code 503. We will now move on to the next stage of this lab, and that is outlier detection. To test the outlier detection feature, we will use a new version of the microservice with the tag 003-exception. This version has a storage problem and it always returns a 507 insufficient storage HTTP status code. So let's deploy this microservice. We'll wait for it to be up and running. We want to configure the outlier detection settings to consider a host unhealthy as soon as 2 consecutive 5xx errors are returned. Also note that we have changed the subset named default to point to the version v2-exception. This would make all the requests to be routed to the version having the insufficient storage exception, so each request to the API will result in an exception. To know the definition of each field that can be set in the outlier detection, please refer to the Istio documentation at the link shown on your screen. So let's apply this configuration to the destination rule. We will now test the outlier detection configuration by calling the customer service using Fortio with one concurrent connection, and we will send 20 requests. You should see that just 2 requests terminated with 507, but then the circuit breaker kicked in, forcing the 503 status code response for the remaining requests. Well, that's it for this lab. Thanks for watching, and I'll see you in the next one.